Distance and displacement. In physics, distance and displacement are both measurements of length. Length is a measurement that's determined in meters. But they're actually very different ideas. Distance is defined by how far you go in total. Direction doesn't matter to distance, so it's a scalar quantity. Displacement does care about direction. Displacement is how far you are from your start point and which direction you are from where you started. Displacement is a vector. Because distance is a scalar, the symbol is d just on its own. Displacement is a vector, so its symbol is d with a little arrow above it to show that it's a vector and that it's different from distance. The unit for both distance and displacement is the meter. Here's an example to give you an idea of the big difference between distance and displacement. Let's imagine a little bug, and it goes on a journey walking around your note paper. And it's quite a convoluted journey. It can't quite decide which way to go, so it just wanders around. From the point of view of distance, we would count the whole trip. For example, this bug's distance might be something like 1.5 meters at the end of the trip, all the way around your page. Displacement only cares about the little place between where it started and it ended. In this case, displacement might be as small as 0.25 meters. And it's got a direction. It's down from where it started. Distance is the total amount walked, regardless of direction. Displacement only takes into account the amount of length from start to finish. Here's an example with numbers. A girl who seems to be pacing walks 5 meters north, then turns and walks 10 meters east. Then she walks 5 meters south. I don't know why she's doing this. Maybe she's doing a physics experiment. In this trip, what is her distance and what is her displacement? We'll start with distance because it's easy. Distance is a scalar. And because distance is a scalar, we can just add the numbers together. 5 plus 10 plus 5 equals 20 meters. We don't have to worry about direction. Displacement is a vector, which means that you have to use vector addition methods to combine the 3 directions she walked. Method 1 involved drawing a tail-to-tip diagram. To do this, we draw the little 5 meters she walked north as a shorter arrow, the 10 meters she walked east as a longer arrow, and the 5 meters she walked to the south as a similar length arrow as the 5 meters north. And we can see the north and south cancel each other out, and all that's left is a 10 meter to the east. So we would say her displacement, D arrow, is 10 meters to the east. Method 2 is when we do math with the plus or minus signs. To do this, we write out the vectors, adding them together, 5 meters north plus 10 meters east plus 5 meters south. And then we convert these directions into plus and minus signs. North is plus, east is also plus. So we have plus 5 plus plus 10 plus minus 5 meters because south is negative. Combine these all together, we get plus 10 meters. But we have to change this positive sign back into a direction, and we take it to be east because that's what our diagram suggests it should be. So displacement is 10 meters to the east.